Here we have to find out the resonance frequency. First of all, we need to know what do you mean by the resonance frequency. Resonance frequency is the frequency where the magnitude of the given closed loop transfer function is going to be maximized. The relationship between the resonance frequency and the parameters of a closed loop transfer function is given as follows. Resonance frequency equals to the natural frequency under root 1 minus 2 zeta square, where zeta is the damping ratio, omega n is the natural frequency. Units are radians per second. We can obtain zeta and the natural frequency from the closed loop transfer function of a given diagram. Now the closed loop transfer function equals to 16 by s square plus 4 plus 16, which is compared with the standard one. From this comparison, we are going to get omega n equals to 4 radians per second, 2 zeta into 4 equals to 4. Zeta equals to 0.5. So if we substitute omega n and zeta in the equation 1, we are going to get omega r equals to 2 root and radians per second. Answer A. Here we have to find out the z transform of a given function x of n equals to cos of pi by 3n u of n. We know cos theta equals to e power j theta plus e power minus j theta by 2. By using this above standard relation, we can write x of n as 1 by 2 e power j pi by 3n u of n plus 1 by 2 e power minus j pi by 3n u of n. By using the standard z transform relations, we can convert x of n into x of z as follows. X of z equals to 1 by 2 1 divided by e power plus j pi by 3 z inverse plus 1 by 1 minus e power minus j pi by 3 z inverse. After simplification, x of z is going to be z into z minus 1 divided by z square minus z plus 1 mod z greater than 1. Here the option is D. From the assertion, we have to decide whether that particular statement is true or not. Here the assertion is given as follows. The stability of the system is assured if the region of convergence includes the unit circle in the z-plane. Means what? Here, for stable systems, the ROC includes the unit circle. Then only the system is going to have both Z transform as well as the Fourier transform. Means that Z transform is going to converge into Fourier transform on the unit circle of a Z transform. Hence, the statement given for the assertion is true. Comes to the reason. For the causal stable system, all the poles should be outside the unit circle in the Z-plane. Here we have to know what do you mean by causal stable system. Causality defined by the ROC, which is outside of the rightmost pole. For the stable system, the ROC should include the unit circle. That means all the poles should lie inside the unit circle. But in the reason they mention the poles are located outside the unit circle, that means the reason is false. Here the assertion is true and the reason is false. Hence the option is C. Here we have to find out the output noise power available at the channel output. Here h of t is the impulse response of the channel and the Rn of tau is the input autocorrelation function. N0 is the two-sided PSD which is equals to the 0.6. Output noise power n square bar equals to double integral of Rn of tau h of u h of v du dv n0 by 2 delta of u by u minus v h of u h of v du dv, which gives the relationship between the output noise power and the input autocorrelation function and the impulse response of the channel, whose value is equals to n0 by 2 u h of n h of t whole square dt, which is equals to 0.1 t cube. Output noise power equals to 0.1 t cube. Regarding part A, the output noise power is equals to 0.1 t cube, which is option A. Now we have to find out the output signal power. Output bit error rate equals to half complementary error function under root EB by N0 equals to 1 by 2 complementary error function under root SNR. SNR equals to EB by N0. Now SNR equals to output signal power by output noise power equals to S by 0.1 t cube. We know bit error rate equals to 0.16. From this, complementary error function equals to 1 by under root 2 equals to S by 0.1 t cube equals to 1 by 2. S equals to 0.05 t cube. Regarding part B, the options are option C is true.